Hello, my name is Haley McClellan and I'll be doing a video on the chain rule. It's part of the unit of derivatives in the calculus course, or grade 12 calculus. So I have the formula here. If h equals f of g of x, then the derivative of h is the derivative of f g of x multiplied by the derivative of g of x, or what's inside the brackets. So let's begin. Again, we have the formula right there, and we're going to begin with some questions. So our answer is 12 in brackets 3x minus 4 to the power of 3. I used the power rule to get I brought the 4 down. I minused 1 with the 4, so n minus 1. And I brought n down to become a coefficient with what's inside the brackets. So I used the power rule there, and then I took the derivative of what was inside of the brackets, or g of x, and then I multiplied it by the coefficient in front of the brackets, which is 4, and then I got 12 in brackets 3x minus 4 to the power of 3. I'm going to explain for the first 3 questions, and then I'm just going to write out the questions and hopefully have you understand them. So I brought 2x minus 1 to the power of 2 up, and it became a negative exponent using our negative exponent laws in exponentials. And then I brought that negative 2 down next to the 3, and I multiplied them together. It became a coefficient instead of an exponent. And then I minused 1 with the negative 2, and it became a negative 3 here and here. And then I took the derivative of g of x, which is 2. I multiplied this one, and this one to get negative 12. And then I still had a negative exponent of negative 3 to the power of negative 3. So I brought this expression down to become negative 12 over, in brackets, 2x minus 1 to the power of 3. And that's the final answer. Moving on. So I brought this expression up, and it became a negative exponent using our negative exponent law in exponentials. And I brought negative 3 down to become a coefficient. I minused 1. And then with that, I got the derivative of what was inside g of x. And I had to bring this expression down because of the negative exponent. So I was left with the answer, negative 3 in brackets 3x to the power of 2 minus 1, and then over in brackets x to the power of 3 minus x brackets to the power of 4, or to the exponent of 4. And that was my answer. Moving on. So with this one, it was a radical meaning a square root symbol. So the square root symbol, using our rational exponent law, the square root is just to the power of a 1 over 2, or to the power of a half. So that's our radical exponent law. So it became x to the power of 2 minus 4 to the power of 1/2. So I brought that coefficient down. It became 1 over 2 as a coefficient, and then I subtracted 1 from negative 1/2, or minus 2 over 2. And then I got negative 1/2, and then I multiplied it by the derivative of what was inside the brackets, aka g of x, and that was 2 of x. So all of this was over 2, and that's what I did. So if you get rid of that 1 and do all over 2, and then I was left with 2 of x at the top, 2x squared minus 4 to the power of half, and I wanted to turn it into a square root symbol again, and then I realized 2 was common on the top and the bottom, so I had to x out those, and I was left with x on the top, so our final answer was x over the square root of x squared minus 4. So that was our answer that we were left with. And moving on. We were left with 8 in brackets 4x minus 1. Pretty simple. We were left with 18x in brackets 3x to the power of 2, or to the exponent of 2 minus 2, all of that inside the brackets to the power of 2. These questions are pretty easy, so I'm just gonna stop explaining and blaze through them. If you would like, you can pause the video in advance, and I'll give you more chances to do that in the future, to write down what is written and to try it on your own. But if you would like a few examples, then you can try them as we go along. So this was another one of the radical ones, and a fairly complicated one because of what is under the radical, or the square root symbol. So taking that in, I turned the radical, or the square root symbol, into the exponent of 1 over 2. And then I brought that 1 over 2 down to become a coefficient in front of what's in front of the brackets. And then I minus 1, or I minus 2 over 2, with the exponent, and I got negative 1 over 2. And then I multiplied it by the derivative of what was inside the brackets, or the derivative of g of x. And then I noticed a square root, or a half, was still left there, so I turned it into a square root symbol, and we were left with our final answer of, in brackets, 2 minus 15x to the power of 4 over 2 to the square root of 2x minus 3x to the power of 5. And now let's move on to the next question. This was another radical chain rule question. Pretty simple if you've seen it done a few times and feel confident in yourself that you can complete this question correctly. Thank you very much. And we have one final question. Now this one is chain rule inside product rule. And it's going to get pretty complicated, and we're going to have a complicated equation for the slope of the tangent. Derivatives, the equation that you see is the equation for the slope of the tangent, and you can use that to find the slope of the tangent at that point if you haven't watched the derivative function video. It's also known as the IROC, instantaneous rate of change, or slope of tangent, or the derivative So here is a very complicated equation for the slope of the tangent. It's using, what you're doing is you're using the chain rule for the derivatives of both g and x. And using that chain rule, you'll get a final equation that's fairly complicated once you've multiplied what needs to be multiplied. Okay, thank you very much for watching. I hope you found the chain rule helpful. I know that the formula is not the same as what you're doing in the chain rule, but follow a few examples, practice questions, and you should be able to get the hang of it. There's two types. There's radical chain rule questions, and there's regular chain rule questions to the power of an exponent. So, with that, practice both. You'll need to know how to do both, and I hope you found this helpful.